Find all zeros in a complete factorization of p of x equals x to the fourth minus 2x squared minus 8. This is in quadratic form. We can actually rewrite this as x squared squared minus 2x squared minus 8. And if we make the substitution, let z equals x squared, we end up with z squared minus 2z minus 8, which can be factored. We use unfoiling. We need two numbers that have a product of negative 8 and a sum of negative 2. Those are going to be negative 4 and positive 2. And replacing z back with x squared, we've got x squared minus 4 times x squared plus 2. Now x squared minus 4 is a difference of squares. We get x plus 2 times x minus 2. X squared plus 2 is not a difference of squares, and in fact 2 is not a perfect square, but we can actually factor this. I'm going to do a little bit of a leap of faith, and I'm going to show you what the answer is, and then we're going to see another way to figure this out. So x squared is x squared, and 2 is technically the square root of 2 squared. And so we would have x plus root 2 and x minus root 2 if this was a difference. But we saw an example in the last problem where it was a sum, and to account for that, we're going to need i's on the root 2. So this is our answer if we're a little bit clever. But if we're not, there's another way to do this. So we know, I'm going to rewrite this over here actually, x squared minus 4 times x squared plus 2. We know that x squared minus 4 has two zeros, 2 and negative 2. We can see that from over here. To find the zeros of x squared plus 2, we can actually set x squared plus 2 equals 0 and solve. If we subtract 2 from both sides, this gives us x squared equals negative 2. And using the square root property, we end up with x equals plus or minus root 2i. So the zeros we have here are root 2i and negative root 2i. And these zeros are the ones that correspond to these factors. Negative root 2i corresponds to the first one. Positive root 2i corresponds with the second one. And of course back here we've got negative 2 and 2 for our zeros. Because whenever we have a 0, that corresponds to the factor x minus that number. And so we can get this factorization either way. And this is our final answer.